Let's see how the memory of the computer works. To store a variable, the memory must know its address. We will use this chess board to mimic the address system. So we will have the letters and we will have the numbers. So for example, if I want to create a first variable, which is a logical variable, it may assumes two values, right? True or false. So the first variable I will store in the address A1. So I will store the value true. If I want to store the value false, the computer will not accept, because this variable cannot have two values at the same time. It's one or other. So if I assign to this variable the value false, the computer will override the information and they will store the last one. If I want to create a second variable, which is with the value true, in the address B1, it will assign the new value here. But the computer is prepared to store different kinds of variables, right? So the next variable that you create will be let's make a comparison here with a text variable. So the name of this piece is king, right? So I will store in the address C1 the characters king. And for the next address D1, I will store a number. So I will store the number 3. Which is interesting because if I want, for example, to change the value of the numeric variable by adding, for example, I can add 1, the computer will just add this value here. If I want to create a new Boolean variable, a new logical variable with the value false, the computer creates a new value in a new address. So in this way, we will have the memory full of variables, each variable with its content, and with each type. The computer will know that the variables A1, B1, and E1, they are logicals. The computer knows that the variable C1 is a text, and that the variable D1 is numeric.
After we saw processes, programs, and functions, I think it's important for us to talk about memory. And Thomas went to rest a bit, so let's talk about memory during this time. So why do we have this memory concept, right? It's like our brain. Our brain, everything that we learn, it stores like as a memory. So everything that we learn, that we see, that we watch, our brain creates connections between the neurons, and these connections are important because they register how we will access this memory later on. So processes, dates, names, images, everything our brain stores. But the computer doesn't have the neurons. They have the memories, and the connection doesn't exist. So the way that the computers store the information is through the binary system. The binary system is composed by zeros and ones, and each group of 8 numbers in binary represents a byte, which is the minimal information that will be stored in your computer. The 0 and 1's combination may represent numbers, may represent characters, may represent colors, may represent shapes, may represent sounds. So everything that our computer learns from our input will be stored in numbers. So to talk about how we name this information that we store in our computer, it's what we call variables. So first of all, when you decide to create a variable, find a meaningful name for that. It will help you identify what this information is used for, and more than that, if someone looks to your code later, they will know what to do. They will know what this means. The variables may assume different types. So in R, we have 4 main types: integers, doubles, characters, and logicals. In each case, we will have its usage. In each case, we will have the purpose to use each variable. When we want different types of variables, we can create classes that will have attributes, which are detailed information about that variable, and methods, which are functions and operations that we can do with that class. But we will leave it to the software engineers. We will not tackle it now. Another research that we can do is to group our variables in vectors, and this part we will see later. So to give you an example about how our variables work, here I have, guess what? Our studio. So once we have our variables, we can assign values to that. The way that you do it is through the left arrow, as you see here in our line 10. So once I run this line of code, that I can do by selecting this line and I press Ctrl Enter in Windows or Command Enter in Mac, I can see here in my environment the variable age with the value that I assigned it. So age, the name of the variable, and its content 42. I will create also a second variable with the name, and I will assign the content Mauricio to it. So this variable has a text. And the last variable that I will create is called bool, from Boolean, which I will assign a value true. So nice. I have now 3 variables with different types of information. So let's see if R understood which type each variable has. So if I use the function print with the function type of, I will get the type of age. So running this line of code, R understands that this variable age, it's a double. But 42 seems like an integer, right? This is the default of how R creates the numeric variable. If we want to convert this double variable to integer, we can use the function as integer. So doing this conversion, we have here integer. For the variable name, what type do you think that we will have? Exactly, character. And for the variable bool, we will have logical. So these are the 4 types of variables that we will cover here now.
What's really worth mentioning is that all this data is going to be grouped into vectors. Vectors are building blocks in R. Any object, more complex or simple, is going to be a form of a vector. Now, what is a vector? You might be thinking, right? Well, a vector is, simply put, a group, a set of data elements put together where the order matters. Okay? It matters which data element is first, second, third, fourth, and fifth. Which brings us to a concept of an index. Every element in our vector has an index. The first element, second element, third, fourth, fifth, and so on and so forth. You can imagine this to work just like a TV channel guide. You have the first channel, second channel, third channel. You might have 60 channels in your cable subscription, right? And when you're feeling fancy on a Saturday morning, you might just want to go to the 50th channel or the 45th channel or the 29th channel. And that's exactly what we do with vectors. Using indices, we can select specific data points in the vector. The 50th, the 45th, the 29th, you name it. We can select specific objects based on indices. And those indices are quoted in squared brackets. Now, having these vectors, again, set of elements, data elements in one object, we can use specific functions on those vectors. If our vector has numbers, it's a numerical type, then we can use a sum function or a min function or a max function to get the sum of all the elements, the minimum value of the vector, or the maximum value of this vector. So now, checkmate! Checkmate! Yes, I won! Woohoo!